My name is Taha Ahmed. My supervisor is Dr. Wadowski. The project I'm working on is speech, computer, and phone control mobile base. Okay, in this video, the robot will be controlled by speech. In this video, we'll cover useful information for the project, how it is done, and how it was tested. In important information, we will look at the block diagram and how the module works, and how it was done. I will cover the truth table, how the program was designed, and how the program works, and finally we'll look at test. This is the speech control robot block diagram. As you can see, there's 4 blocks in the block diagram of the speech controlling robot. The speech module is used to recognize the speech commands of the user to direct the robot. The Arduino is used to control the robot, go right, left. The output of the microcontroller digital pin, its current is small, about 40 milliamp, which is not enough to run the motor. So a motor drive or transistor is used to amplify the current for the motor. The motor allows the robot to perform the actions. I drew a diagram to summarize how a speech program works. First, a make of the system, train the system. The speech is recorded, stored in the memory. When I use a speak to the system compares the new spoken word to the stored one. If one is similar to the new spoken word, then a specific action for the specific voice command is executed for the specific speech command. The aim of this project is not to give detail on how speech recognition works, but to do the project. But after the completion of the project, I have looked in detail on how speech recognition works using MATLAB. This is the speech project truth table. The speech truth table is the same as the Bluetooth truth table, except there is some difference, such as the button of the Bluetooth commands is not written. It's not written in the situation column. Here the right continuous and the left continuous that was appear here were not included. Stop was changed to break because recognition for break was better. Otherwise the rest is the same as the Bluetooth truth table. So to understand how the truth table was created, just look at the Bluetooth video truth table part. Okay, we start and end the flowchart with the start and end block. First is initialize and define. Block happens where the ports are given a name, define it, and the variables to the speed variable are initialized to a given value. Similar to the Bluetooth flowchart, the same pin names and variables were used to be consistent. First, a trigger word must be set for security reasons. To keep the security simple for this project is called the robot. This is represented by a decision block, as you can see. Then the user can see any speech commands of the choice, and this is done using if statement. For each speech commands, one if statement. Under the if statement, the action for the specific speech command is written. For example, for forward, all ports are turned off. Only the forward motion left and right outputs are turned on to allow the robot to go forward. A decision block is used to represent an infinite loop, a loop that will run continuously. After you have trained the commands, there is a button on the EasyVR commander that generates a code for the commands that you have created, train it. What you have to write is the particular action to perform on a particular speech command is recognized. So okay, let's go through the code. As you can see, there is a header allowing other people to understand what's going on. Then this code was added. The post name and variable have to be defined. Then you have to make the port names as input or output. All of the ports are made as output because to control the motors and LEDs. Okay, here we have the void action. In the flowchart there's a trigger word that had to be set first, then the speech command had to be set. Here the same thing happens. We have the trigger word, then we have the speech commands in group 1, all listed one by one. For each speech command, the particular action code was written from the truth table. Let's test the robot with speech. Its trigger name is robot. Let's first turn it on. Robot. Forward. Brake. Right. 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 Forward. Brake. Backward. Brake. Left. Up. This is speed up. 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 Down. Speed down. Brake. Right. 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 Speed down. Down. This is the slow speed. Up. Up. Down. Down. This is the lowest speed. Brake. Okay. Everything was tested and every voice command, every action was performed. The test was successful. Finally, I wanted to say one more thing is thank you for your time and hope you have learned something useful. Goodbye. Okay, I'm gonna show you how to train a command and how to test it. So first plug the USB which is connected to the Arduino and the shield. Press the connect button. Now it's connecting. It's loading the data. Alright, let's go in group 2 and train a command. First, add button. Let's call it robot. To train it, you press on this button. Robot. it's good to train it once near and once a bit far, about 1 to 2 meter, so that this is the average distance, average height of a human, of a person. So let's train it twice. Robot. Now let's test it if it can recognize. Robot. It went green. This means that it did recognize the voice command that we just trained. So now I have done for all the action for the robot, which are forward, max forward, increase speed, decrease speed, left, right. Okay, now I'm going to test all the voice command I created for the robot. Decrease, forward, backward, right, left, stop, max forward, increase. Okay, all voice commands have been tested and they were all correct